Zero trust is a term you hear often these days, and zero trust can mean different things in different contexts. One key reason there's so much ambiguity is the diversity of use cases to which it applies. Here's a quote from Alvin Toffler on the need to focus on the smaller things in order to do big things. Toffler, by the way, was the person who coined the term information overload, so he clearly would want this section to be efficient and full of clarity. Just from a definition standpoint, zero trust is, to me, a set of mechanisms that focus on providing security controls around digital access and assets, while not solely depending on traditional network controls or network perimeters. In other words, we aren't going to trust a user based only on their location within a traditional network. Instead, we want to augment network-centric models with additional techniques, which we would describe as identity-centric controls. Now, keep in mind that another primary concept of zero trust is it should include attributes such as usability and flexibility. We all know that you can secure a safe at the bottom of the ocean if you put it in a block of concrete, but it's not a very usable tool at that point, is it? In terms of the keys to zero trust, let's look at two key dimensions. The first being the network itself. You're always going to have some notion of a perimeter in security, the thing that surrounds the thing you're protecting, or the things. It may be more than one. For example, in many scenarios, a proxy is trusted in part based on its network properties. Most of the time, people are designing systems so that traffic from specific internal IPs is considered trusted. Or maybe you have a set of containers on the same host running as part of the same application deployed by a single DevOps team, and that's within a trusted perimeter. So the question becomes, where is my perimeter? How big or small is it? And you should make it as small as possible. And how easy is it to monitor and audit? And in terms of effectiveness and user interface, should we use a VPN for network isolation, but make it dynamic and hidden from the user experience so that users don't even notice that network boundaries are being created and torn down as needed? Or perhaps we break systems down into even smaller logical components and go with tighter network segments or even packet-level controls around some applications. What we consider microsegments or microperimeters. Do we add in some kind of a gateway or proxy technology that enforces a newer kind of a trust boundary down the road? How about a combination of those techniques? And if those are the questions that come up when you're securing your network, a second consideration is always identity and access management. This again runs the gamut of use cases from humans with PCs or tablets or phones to machine or software communications. Across those types of use cases, we can see that identity, authentication, and authorization techniques can be much more different in practice, right? People don't talk to machines the same way that software talks to machines. And this leaves us with open questions around how to secure. Should we organize around security relevant properties of the end user profile, or maybe we want to alter access dynamically through some other factor, such as the strength of the authentication, the device type, the network location, the time of day of week, etc. Now then, identity-centric perimeters can be used to interact with AWS API endpoints, and they uniquely authenticate and authorize each API request. However, network-centric tools such as Amazon Virtual Private Cloud, security groups, private link, and VPC endpoints are also easy to implement to filter out unnecessary noise, which allows your security inspection services and your staff to focus on just the components that are important. But really what we want is for these two types of controls to not only coexist, but be aware of and augment one another. A real-world example here is VPC endpoints provide the ability to attach a policy to enforce identity-centric rules at a logical network boundary. So the two concepts, network and identity, share the same underlying principles, even if they differ in what they're trying to achieve for an organization. We want to focus on the problem we're trying to solve because zero trust can mean different things in different contexts. One key reason there's so much ambiguity and confusion around the term might be the diversity of use cases to which it applies. But by focusing on the problem you're trying to solve, we'll spend our time improving security posture and outcomes and avoid getting mired in low-value discussions. One of the discussions we have in Amazon quite frequently is around not trying to solve the entirety of the problem all at once, And I'll tell my teams, give me an 80% solution right now and let's iterate towards the final outcome. The same's true here. Constant steps of improvement. We believe it's best to think of zero trust concepts as additive to existing security controls and concepts, really rather than replacements, because one size does not fit all. We want to focus on the value of the systems and the data that are being protected. Over time, the application of a zero trust conceptual model will continue to improve defense in depth and continue to make security controls we already have work better. Use zero trust concepts to raise your security bar, but don't issue blanket standards that lack flexibility. For many business systems, network controls and network perimeters will continue to be important and sometimes adequate controls. If we begin to look at the three use cases I just referenced, the first is to consider machine-to-machine communications. This is about authorizing specific flows between components to eliminate lateral network mobility risk. Basically, if two components don't need to talk to one another across the network, they shouldn't be able to talk, even if those systems happen to coexist within the same network or network segment. This greatly reduces the overall surface area of connected systems and eliminates unnecessary or unneeded pathways that an adversary might take advantage of, particularly those that lead to sensitive data. For this use case, our discussion should begin with security groups, which have been a part of Amazon EC2 since it launched. The point of security groups is to provide software-defined microperimeters. They also act as a kind of identity system, in which group membership becomes relevant for determining whether or not to permit a particular network flow, allowing for extremely granular rules without the burden of keeping them up to date as membership in the group ebbs and flows. Another way to get at this would be AWS Private Link. Using Private Link, a load-balanced endpoint can be exposed as a narrow, one-way gateway between two VPCs, with tight identity-based controls on who can access the gateway, as well as where any incoming packets can land. VPCs don't even need to have routes between one another, so the outcome here is going to be robust machine-to-machine network security. Our second zero trust use case, human to application, is about improving workforce mobility without compromising security. Right now, especially with higher levels of work from home, this is one that's clearly on everybody's mind. Now, traditionally, these applications existed behind a strong VPN front door. However, VPNs aren't always compatible with the full range of mobile devices that modern workforces leverage. So the objective here is to make the locks on applications effective enough that we can eliminate a VPN-based front door altogether. Depending on your risk tolerance and developer maturity, there are a lot of options out there. At one end of the spectrum, you may want a desktop as a service, which we offer as AWS Workspaces. Or you'd prefer an end-user application as a service product, like AWS AppStream. Once you've got into that place, traditional security controls are then applied to the intermediary services. So a user with a PC or an HTML5 client can reach virtualized applications over the internet. Now you've got a desktop-like experience without having to worry about the security of the final device in the user's hands. The other end of the spectrum is connecting internal web applications directly to the internet. For this, we recommend a combination of AWS Shield, AWS WAF, and Application Load Balancer. Going down the line, that would be leveraging AWS Shield for a managed DDoS protection service, AWS WAF as a web application firewall, and then authentication through the Application Load Balancer in order to integrate with an identity provider to offload the work of authenticating your users. Using this combination, your internal custom applications quickly become just as flexible as software as a service applications, allowing your workforce to enjoy the same from a coffee shop flexibility while unifying your application portfolio under a common security model. And finally, our third zero trust use case, which is markedly different from the first two because it involves securing digital transformation projects such as IoT. This could be a connected vehicle use case where a car needs to relay a stream of instrumentation data over the internet to a cloud-based analytics environment. Historically, these types of workloads have always existed entirely outside the traditional enterprise network, so they require a security model that accounts for that particular situation. Here's where you want to use services that can issue unique device identities to every device in your fleet and then use those identities and associated access policies to securely control how they communicate and interact with the cloud. And of course, I'm recommending services like that, but I'm also recommending you take a look at our IoT Device Defender service. But sales recommendations aside, we do think this use case will continue to expand as we see more workloads move closer to the edge to minimize latency and to improve user experiences. So to wrap this topic up, what I'd really like to see security practitioners focusing on are the principles of zero trust that increase your security posture. Don't segment out your identity and network security. Instead, make them complementary. Your controls should coexist and augment each other. And then it's about the use case itself. Is it machine to machine? Are humans involved? Is it IoT? This is going to be where you're making security decisions that are appropriate for the things you are trying to protect against and to protect. And lastly, something we always advocate for at AWS. Don't put inflexible mandates in place. Give yourself and your team room to grow with the technology that's out there.